Hi, my viewers. It's your girl, Linda. You're highly welcome to my YouTube page. If you are joining me for the first time, you're also welcome. Don't forget to like, comment, and subscribe to get updates. So I created a video regarding linear programming about minimization in linear programming. I created a video. I'm going to drop the link to the link for this video in the comment section so that you know where I'm coming from, or you will have an idea of what I'm trying to work on. So in the comment section, I got a message. Someone asked me that they don't understand how to get the corner point ABC, which are this corner point ABC. So this video is more of like it's more of like a video built on this content, but it is me trying to go deeper on how to calculate the corner point when plotting the graph. So this the in the video that I was talking about, the video for this one, the video to this question has this graph. You could see that most of the graph is kind of big, and the video is not really capturing the total values of the graph. So I decided to recreate the graph in such a way that each values shall be captured. So this is me recreating the graph. You can see that every value is being captured. So these are the two constraints that are present in the question. We have the materials and the label. What are constraints? You can kindly make reference to the previous video. I explained in detail what the constraints are and how to derive at these values. We have your label and your materials. So when you're done computing up to this level, you can see you have your label and the material with the x and the y values. So the step one is that you have to make sure that each values that are present for both the label and the materials are well captured in your graph. Now for the x-axis, you will notice that the lowest value is 0, and the highest value for both the label and the materials, the highest value is 8. So for your x-axis, you must make sure that both the 0 and the 8 are included. So you can stop at 8 here. It's okay, but they just me adding additional. So this 9, 10, 11, 12 are not really important. What you really need is, as long as this 8 is inclusive, which is the highest value, you're good to go. So remember, this is your x-axis, and this is the y-axis. So for your y-axis, the lowest value is 0 and the highest is 12. So you could see that in my y-axis, both the 0 and the 12 have been captured. 0, so that whenever you are plotting it, you'll be able to get the values. Now let's start from the label. When my x is 0, my y is 12. When my x is 0, my y is 12. This is one. And the second one is when my x is 2, my y is 0. When my x is 2, my y is what? 0. So you need to join this 12 and this 2 using your ruler. So this line I just created, this intersection here, is just for the label. And the label equation is 6x plus y plus 12. So I'm just going to label here to be label. This is a label constraint, of whose equation is 6x plus y equals to 12. So that is for the label. So the next thing is for the materials. Remember, this is linear programming with two constraints. The two constraints here are the label and the materials. So for the materials, if your x is 0 and your y is 8, your x is 0, your x is 0, your x is 0, and your y is 8. That's for the first equation. Then for the second equation, my x is 8 and my y is 0. Your x here is 8 and your y is 0, which is this. So you need to join this 8 here to this 8 here. Yeah, like so. So the second line here is for the materials. of whose equation is x plus y equals to 8. X plus y equals to 8. So after plotting it, we shall now arrive at our corner point. For us to get our corner point, this 8 here shall be our corner point A. This shall be corner point B. This shall be our corner point B. You can see these are like more of like the intersection or like the boundaries. So we have the boundary 1, boundary 2, and the boundary 3. So this is corner point A. This shall be corner point B, and this shall be corner point C. So this is how you derive at your corner point. So because in this question we're dealing with total cost. In this video, when I made this video, I made it known to us that when you're dealing with total cost, as a business-oriented personnel, you are to minimize your total cost. Hence, we are dealing with the minimization. And we are dealing with minimization. The inequality to be used shall be the greater than or equals to inequality. And when you are using this greater than or equals to inequality, the shading shall be above the boundaries. This is boundary 1, boundary A, boundary B, boundary C, or you call it corner point A, corner point B, or corner point C. So you shade it, you shade outward like so. And this side is what is known as the visible region. Now the next step is for us to arrive at the values at each corners. So from this corner point A now, so you have to look for the x and y. This is x and this is y. What is my x here? My x here is what? 8. And my y here is 0. That is for this corner point A. For the corner point C, what is my x and what is my y? My x here, which is, if you trace this point, so the x here is 0, and your y here is 12. Then the corner point B, what is my x? Now, there is a little calculation that will be done here. The x and the y. So what is my x? You know, my x is somewhere downward, and this is the point of intersection. So you trace this point here. So where does it fall to? So this line falls here. It falls here. The line falls here. That is, it falls before 1. So this should be 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4. 0 0.4. And so this is 0 0.4. Like I said earlier, I made this video to make sure that every values in the graph is being captured. That was why I reduced the unit. So each of these lines represent 2 units. So when you have 0, 1, 2, 3, 4, this is where you stop. That is 0 0.4. So 0 0.4 times 2, that will be 0 0.8. So that's how we got to 0 0.8 here. Then for the y-axis, just come here. This is the point of intersection. Just trace it this way. So this place is 7. This is 7, 7.1, 7.1, 7.1. So that should be, yeah, 7, 7.1. That'll be 7.1. In the previous video, I got 7.2, but here I'm getting 7.1. But it doesn't matter, provided they are kind of close to each other. We are fine. We are good to go. So that is all. Please, if you have any question, kindly know. So after computing for the corner point, which is A, B, and C. So corner point A, x is 0, 8 and 0. Corner point B is 0 0.8 and 7.1. Corner point C is 0 and 12, which is what I have here. So you create your solution table. This is the corner point. This is the x-axis, y-axis, the cost equation, which is the total cost here, 4 and 6. So this is the z value, that is the value that should be minimized, which is the total cost, which is 4x plus 6y. So this is the z, 4x plus 6y. So you have to calculate your total cost. So for your corner point A now, the x is 0, the x is 8 and the y is 0. So we have x and 8. So you have to substitute x to be 8 and y to be 0. So 4 times 8 plus 6 times 0, that should give you 32. You do the same thing for the corner point B and C. It is 0.8 and 7.1. So 4 brackets, substitute x to be 0.8, substitute y to be 7.1. Okay, this is 7.1. So for corner point C, you substitute your x to be 0 and your y to be 12. You evaluate it. So since you're dealing with total cost, so you need to check the lowest cost, which is 32, and which is at corner point A. So the optimum solution is at corner point A, of which the total cost is 32 naira, where x is 8 and y is 0.